Alrighty. In today's video, we're going to be talking about lesson 9.7. This will be the conclusion of chapter 9, and then we'll actually skip to chapter 11. We will not be doing the rest of chapter 9 or chapter 10. So that's the last thing you needed to know in chapter 9. This will be the dot product. All right, so a couple things to pull out of this lesson. Um, the dot product is basically meaning if you take two vectors and multiply them together. So given that u is equal to vector u1 and u2, and v is equal to vector v1, v2. All right, so that means then to do the dot product of u times v, what you're going to do is multiply their corresponding values, but then we add them. So what happens is when you multiply two vectors together, you actually get a single number. So this would be u1 times v1 plus u2 times v2. So notice I'm adding, so when I actually get my answer, I'll get a singular answers. Now we do have a few properties of dot products. So things that will hold, that will kind of help you go quickly through the math, rather than having to guess, is this a legal mathematical move or not? All right, so the first thing is the dot product UV is actually equal to the dot product VU. So they are a commutative, so it doesn't matter the order, you would still get the same answer. If you take a scale factor 0 and you multiply it to a vector, you will get a single number 0. So if you do the dot product with 0, you do get 0. So this is not the same thing as doing 0 times the as a scale factor u and getting the origin. This would actually equal 0 if it is the dot product that's being done. The third thing, if you take um, a vector u and you multiply it to vectors v plus w, you can actually distribute it out as uv plus uw, and you would produce two different dot plots that would dot products that you would get two different numbers, but you would still add them to one singular number. The fourth thing is saying concept in a sense that if I was multiplying everything, so let's say I had let's go with A times UV. This is the same thing as AU times V, and the same thing as, well, I guess I could say U times AV, like this right here. All right. So again, making the dot product of this. And the last thing is if you actually take the dot product of two of the exact same vectors, it is the magnitude squared. So if you wanted to find the magnitude of using dot product, you could actually multiply the vector by itself and then take the square root of the result. So therefore, I could actually find the magnitude by doing the dot product of itself. And now I would have the magnitude. So another route of finding the magnitude. And in the homework, it asks you to use the dot product to find magnitude as well. All right, so then after this point, there are a few formulas that come from this. So if I wanted a different route for the dot product, I could say it's the same thing as the magnitude of u times the magnitude of v times the cosine of theta. So let's say you are asked to find the dot product of u and v, but you're only given an angle of the two and the magnitude without having to go backwards and find out what their vectors are and then go and multiply them out. I could just go straight to this formula. Now with this, we also are talked about orthogonal vectors. And orthogonal just means perpendicular, which just means if I take vector u times vector v and I do the dot product here and I get 0, that means that those two vectors are perpendicular to each other, or also known as orthogonal vectors. We also have parallel vectors. If two vectors are parallel, then you can either write the vector u as a multiple of vector v, or you can write vector v as a scale factor of vector u. So basically meaning if I'm able to pull a scale factor out of either one of the vectors and it be that scale factor times the original vector, then you know they're parallel. So when you're trying to determine if something's perpendicular, parallel, or neither, you start by determining, well, is it perpendicular? Because that's super easy to determine if the dot product is 0. And if it's not perpendicular, then you start looking at the vectors going, all right, can I pull a scale factor out and then be left with the other vector? If I can, then I know it's parallel. If that doesn't work, then it's just neither, and we'll talk about some of those throughout the day. All right, after that point, it goes on to the one last thing, and this is just talking about projection. So we can project a vector onto another vector. So if I want a projection of u onto vector v, it is denoted as PROJ for projection of u onto v. So projection of whatever you're projecting onto whatever you're projecting onto. To do the math here, it will be the dot product of u times v divided by the magnitude of v squared times vector v. So if I'm projecting another vector onto this vector here, this will be the process. And then we can use that to help us find different answers as well. It's pretty much everything that's within that chapter or section. So let's kind of do a lot of examples to make sure you have plenty of them for your homework. All right, so for number 1 here, it says calculate each of the following dot products. So we have 4, 3 dot 5, -1. So we're multiplying these two guys up. So the way, again, we do this is you simply will take their corresponding x values and multiply them together. So that'd be 4 times 5 plus you would then take their corresponding y values. So that'd be 3 times -1, which gives us 20 minus 3. So you get 17 as the dot product. That's all you have to do on a dot product, is you literally just multiply their x's and then multiply their y's and then add the two products up. Right? Let's do another one in a different, present it to you differently. So let's look at number 9. You are told u equals 5i plus j, and v is equal to -2i plus 3j. All right, so again, you're wanting to calculate the dot product. So I want to know what is u times v. So remember, this is still your x times your x. So that would be 5 times -2 plus, there's no number there, so there's an imaginary 1. So you take your y times your y. So that'd be 1 times 3. So you get -10 plus 3, which gives you -7. All right. Hopefully pretty easy so far. Let's look at different ways he'll ask you these type of questions. So let's look at number 11. It says find the indicated quantity given u and v. So again, it tells you that u is equal to -2 comma 3 and v is equal to 4 comma 4. I think if I remember correctly on the homework, this question has 4 parts to it. Basically 11, 12, 13, and 14. So when we look at number 11, that was just V times V. So when I work this out, that's just going to be 4 times 4, but it's itself, plus 4 times 4, because it's itself. So I'm not doing 4 times 4. I'm doing this value times this value plus this value times this value. So that gives me 16 plus 16, which gives me 32. All right, let's look at number 12. Number 12 is 4u times v. So what we can do here is we can apply the 4 to the vector first. So that would give me -8 times 12. So I'm taking the 4 and I'm multiplying it to the u. Now I'm going to multiply that to 4. So now that gives me -8 times 4 plus 12 times 4. So that's going to be -32 plus 48, which looks to be like 16. Right. Let's do another one. Let's look at number 13. This one is going to be u times u. So there's the dot product there. It has to have a dot there. So notice this one did not have a dot. So that was a scalar 4. This one does have a dot. And then there's not a dot here, which now indicates that I need to find this guy and then multiply it to this vector. So first figure out u dot u. So that's going to be -2 times -2 plus 3 times 3 times the vector u. So in this case, that's going to be -4 plus 9 times the vector u. So that would give me 5u. So now I take the 5 and I multiply it to the u. So my final answer here would be -10, comma 15. Oh my goodness. I messed up. -2 times -2 is not a -4. It is a +4. So this would be 4 plus 9 times u, which would then be 13 times u. So using the correct number, -2 times 13 is -26, and then 13 times 3 is 39. All right, watch out for stuff like that. But there you go. There's how you would do it. So again, notice that this is the dot product, which gave me a scale factor, and then that scale factor is then distributed in as a vector. All right, let's look at one more with these examples. So let's look at number 14. This will be u dot v and then 2v. So what I'm going to do is I'm going to do the dot product of u and v. So that would be, we already done u and v. I don't think so. So, okay, so this would be -2 times 4 plus 3 times 4 times 2v. So that give me -8 plus 12 times 2v. And then this becomes 4. And then I'm going to go ahead and take this 2 and distribute it into my v. That'd give me 8 and 8. You could have done 2 times 4 and got 8 and multiplied it, and you would still get 32 and 32. Either process would have worked there. But again, I could have waited and done 2 times 4 to get 8 and then multiplied it to 4 and 4, or you could do it through this process. Both of those are completely correct. All right, so that should give you plenty of examples. Let's look at then a different type. Let's look at number 15. So this one says find the magnitude of u, but using the dot product. So this is u equals 6 comma -1. Now I know I could do the square root of 6 squared plus -1 squared. But using the dot product, I know that the square root of u dot u would give me the magnitude of u. So that's what I'm going to do here. So I'm going to do the dot product. So that's going to be 6 times 6 plus -1 times -1. So it gives me 36 plus 1, which gives you 37. Notice by doing the dot product here, 6 times 6, that's the same thing as 6 squared. -1 times -1, that's the same thing as -1 squared. So just know that just because it's a different formula, it's literally the same process. So there's your magnitude. All right, let's look at number 17. Number 17 is written as U equals 2I plus 7J. Again, using the dot product, this would be 2 times 2 plus 7 times 7. So that come out to 4 plus 49, which will give you square root of 53. All right, so again, that's just using the dot product to give you the magnitude. All righty. That was number 17. So let's look at number 19. All right, number 19 says find the angle between the given vectors. So you're given u equals -2, 3, and v equals 1, 0. All right, to find the angle between these two vectors, we're going to use that formula from earlier given this. So you were told that u dot v is equal to the magnitude of u times the magnitude of v times the cosine of theta. I need to find theta. So to do this, I'm going to basically go, all right, well, this is going to be u, the dot product of u and v. I'm going to take this and move it underneath. So I'm going to divide it. So now this is going to be the dot product of u times the dot product of v. This will now equal cosine theta. Remember, to get rid of cosine, I can do the cosine inverse of the dot product over the magnitudes multiplied together. So there's a new formula. So you can actually now go straight to this formula by doing the work. So here we go. So doing the dot product at first. So I'm going to do cosine inverse. So dot product would be -2 times 1 plus 3 times 0. Do the magnitude. So let's do some little side work here. So the magnitude of u would be -2 squared plus 3 squared. So I give you 4 plus 9. So I give you 13. Magnitude of v will be 1 squared plus 0 squared. Which gives you 1 plus 0, which gives you 1. Square root of 1, which is just 1. So this would now become square root of 13 times 1. So then this becomes cosine inverse of -2 plus 0 over the square root of 13. And then one more simplification. This would be -2 over the square root of 13. Now, a couple of things to look here. You could have skipped some steps if you just saw this and you can go straight to there. I would have been okay with that, but just make sure you understand. So I'm going to go to my calculator. I'm going to go to trig. I'm going to go to cosine inverse, and then I'll do control divide, and I'll do -2 over the square root of 13. My calculator is in degrees, and that is what your test is going to, or your homework is going to want as well. So make sure your calculator is in degrees. And in the calculator, I do get 123.69. The only thing you got to watch out is remember, this is like, what is it? Cosine is adjacent over hypotenuse. So the x value has to be negative, and since the hypotenuse will always be positive. So that either happens here or in here. So since I got an answer here, I'm good with that. And then there will be your answer. So just gotta make sure you're in the right quadrant as well. All right. So that concludes that. So let's look at another type of question. Oh, nope, same type, different. Present it to you differently. Let's look at number 23. All right, number 23 is presented to you as u equals -I plus 2j, and v equals 3i minus 3j. So remember, theta is now equal to cosine inverse, the dot product of u and v, over the magnitude of u times the magnitude of v. So I can go straight to this formula now. So this is imaginary 1 right there. So that's going to be a negative 1 times 3 plus 2 times negative 3. And then I just need to find their magnitude. So the magnitude of u would be negative 1 squared plus 2 squared, which gives you 1 plus 4, which gives you the square root of 5. The magnitude of v would be 3 squared plus negative 3 squared, which will give you 9 plus 9, which gives you 18. I'm not going to concern myself on simplifying these radicals. I'm just going to leave it as such. And the reason is because at the end of the day, I'm going to just plug it into the calculator to get a degree symbol. So when I work this out, I'm going to kind of skip a couple of steps. Negative 1 times 3 gives you negative 3. 2 times negative 3 is negative 6. So we do get a negative 9. 5 times 18, what's that going to be? 50, 40, 90. So you get square root of 90. Again, I wouldn't worry about simplifying. I would just go ahead and plug that into your calculator. Be different if it did ask for an exact answer, because then I would have to then go back and simplify that. When I do that, I do get 161.57 degrees. Make sure we're in the correct quadrant. And because this is negative, it needs to be in their quadrant 2 or 3. It falls in quadrant 2, so we are good. All right, let's look at another one of this type. Probably do it right here. Let's look at change colors real quick to this one's nice. Let's look at number 25. So this would be given to you as u equals cosine of 3 pi fourths I plus sine of 3 pi fourths j, and then v is equal to cosine of pi halves I plus sine of pi halves j. All right, because it's in this form, just to give you an FYI, it's going to want an exact answer. So we won't be able to use the calculator here. We'll have to use our unit circle. So the first thing we have to do is write it so that we can do a dot product. So 3 pi fourths, that's 1, 2, that's right here. So that would be negative square root of 2 over 2 and then square root of 2 over 2. So this right here would then just give me a negative square root of 2 over 2i plus square root of 2 over 2j. This one here, pi halves, is located right here, and that's at 0, 1. So this gives you 0i plus 1j. So when we produce the, we're still looking for the angle, right? Yeah. So using the formula up here, this would be cosine inverse of the dot product. So that's going to be negative square root of 2 over 2 times 0 plus the square root of 2 over 2 times 1 over their magnitudes. So their magnitudes would be negative square root of 2 over 2 squared plus square root of 2 over 2 squared. When we do this, this will just make a 2, cancel out the square root. So this gives you 2 fourths plus 2 fourths, which is 1. Square root of 1 gives you 1. So that's 1 times, same thing over here, 0 squared plus 1 squared, which ends up just being 1 as well, because again, 0 plus 1, square root of 1 is 1. So this kind of makes it a little bit easier. This is now cosine inverse. This will go away. I really don't need this, so I'm really just left with square root of 2 over 2. So what that means is, where on the unit circle is the square root 2 over 2? Well, that happens either here or here. So since my vector here is in the first quadrant, and so is, well, in this quadrant here and in this quadrant here, my angle is going to be like this. I'm really looking for this angle right here, which is less than 90. So that means I must be falling in the first quadrant, and that happens at pi fourths. Right? So that's kind of how you have to figure that part out, is kind of know how big is my angle that I'm looking for. Now, again, you could have typed this probably in the calculator as well, and then you could have gotten a decimal, and then kind of go, all right, well, I know 45 degrees. Actually, I think the calculator would have gave you exactly 45 degrees, and then just know that's the same thing as pi fourths. I bet they take both answers as an FYI. So maybe we could have just plugged that straight into the calculator. All right. So always good to know how to do it by hand, though. All right, but that's it on those. Let's look at a different type of question. So let's look at number 27. Number 27 says use vectors to find the interior angle of the triangle, giving the following set of vertices. So here we go. So let's kind of quickly go through this. So it's going to be 1, 2, 3, 1, 2, 3. Here's my first point. Then I got 4, 2. Here's my second point. Then I got -1, 1, 2, 3, 4, 5, 6. Here's my third point. So I have somewhat of a triangle that looks like this. Cannot assume any of those are 90. But what we can do is we can actually kind of figure out what these sides are going to be. And then given the sides, I can then just figure out the angle. So what we're going to do first is let's just name these. So we'll call this U, we'll call this V, we'll call this W. What I'm going to do is I'm going to actually find like the magnitude of these guys. And then once I find the magnitude of these guys and their vectors, I can do the dot product over their magnitude to take the cosine inverse, and it's going to give me the angle in between. So here we go. So to find vector U, again, to go from one spot to the other, if you don't know that already, this right here could be like this, this, and this. So that means that this is my initial point. This will be my terminal point. So to draw this out, again, this point was 3, 3, and this point right here was 4, 2. All right, so if we call this my first point, so this is where I started, and then I went to this point, to be the second point, then to find the vector, I could just do x2 minus x1, and then y2 minus y1. So in this case, I could do 4 minus 3, which is 1. And then I could do 2 minus 3, which is -1, which is the same concept as going right 1, down 1 as my direction. Ooh, got the 1 there. So there's my vector there. Let's do our vector v. Again, this right here was -1, -6. So again, this is the end point. So what I could do is I could go, all right, -1 minus 4, that'd be -5. So that means it went to the left 5. And then this is -6 minus 2, so that's -8. So again, that means it went down 8. So left 5, down 8 to get to this point. And then we could do W as well. And really, once we find two of them, we can kind of guess the last. So I guess the last one. We can subtract from 180 and know what the answer is. All right, so this will just be 3 minus -1. So that's 4. So that means it went back over 4. And then this would be 3 minus -6. So that'd be a +9. So that went over. So there's your parts right there. All right, once we have this information, we got our U, got our V, our W. So we can find this angle here, we'll call theta. We'll do it in red for your starts. But if I want to know what this right here is between U and V, all I got to do is the cosine inverse of the dot product of U and V. So this will be U times V over their magnitudes, just like we did earlier, just now in applied. So in this case, that would be cosine inverse of 1 times -5 plus -1 times -8. And then just find their magnitude. So the magnitude of U would be 1 squared plus -1 squared. So that'd be 1 plus 1, which is 2. Magnitude of V would be -5 squared plus -8 squared. So I gave you 25 plus 8 times 8, 64. 25 plus 64 Would that be 89? Yeah, I leave it like that. Again, it's not going to matter at the end. This one then would be the square root of 4 squared plus 9 squared. So that would be 16 plus 81. So that would give you 97. All right, so there's your all your information you need for the rest of the work. Now we do 2 times v would be 89. So in this case, I get cosine inverse of -5 plus 8. That'd give you 3. 2 times 89, 180 minus 2, so 178 square root. And then we can figure out what that answer is. So we'll go back to our calculators. We get 3 and then square root of 178. That comes out to be about 77.0. So I'm just going to keep it at 77. So that would mean that this angle said, did I mess up anywhere? Hold on. 1, -5, that give you -5. -1 times -n is negative or +8. They give you +3. 90 times 90 is 180. So I give you, okay, so it's 178. Square root of 178. Got 3. Looks good. All right, so 77 degrees. Mm. Reason I'm stumped, they say this answer was 69, but our work looks really good. So again, 1 plus 1 gives you 2. 25 plus 64 is 89. 16 plus 81. Well, we don't need this, but it does give you 97. Hmm. Well, let's just carry on. I don't see anything that's wrong with our math, as the book can be wrong as well. Or maybe you're yelling at the screen going, hey, you forgot to multiply like this. All right, but this is what I see. I'm not seeing anything incorrect. All right, so then I'll then find this angle here. Again, now using V and W. So now this angle would just be cosine inverse. Again, I want to do V and W. So that's now going to be V times W over V, magnitude of V times the magnitude of W. I could have gone this way as well. I could have done W and U if I wanted to find this angle. Totally fine. And then so therefore, if I do the dot product of V and W, that would give me cosine inverse of 4 times -5 plus -8 and 9 over their magnitude. So that would be the square root of 89 times square root of 97. I might just type it like that. So I'm going to do cosine inverse. That's going to be -20. This is going to be -72. So that would give us -92. And then I'm just, again, keep it like this. And then type in the calculator. So here we go. Because this definitely is less than 90, so it should be the first quadrant. I was checking that too. All right, so negative 92, 89 times the square root of 97, and I get 170, we'll just call it 172. So maybe that isn't correct. There's no way that you can have 172 there, because again, that would be negative 20, negative 72, negative 92. That angle's definitely got to be smaller. Oh, and it is, because again, I can see that this is definitely less than 190. So all I have to do, so this is I'm glad this popped up. Hold on. Because again, since I know that that has to be less than 90, all I have to do is take this and subtract it from 180. When this happens, we haven't had a situation where it happened yet until now, and I get 8. So since I get 8 degrees, I can then now find that last angle. So we get 77 degrees, 8 degrees, and then 180 minus 77 minus 8 gives us 95. So then we get 95 degrees. I will say this is the same answer that the book got too, but these two aren't. And again, there could have been a little multiplication issue here, but I'm not seeing it. And I've gone through it twice. But again, maybe you're yelling at the screen. So if you notice it, definitely holler. Let me know. Other than that, they might have just messed up on themselves, but this is what I've calculated. And I can kind of see too that this angle opens up a little bit wider than this angle. So this makes sense that this is more than 90 degrees. All right, so there's that. So then we take that and now let's look at a different problem that you'll see. Let's look at number 31. 31 is find the dot product U and V, where theta is the angle between U and V, given the magnitude of U, the magnitude of V, and theta. So in this case, that would be using this fact, the dot product, the same thing as the magnitude multiplied together times cosine of theta. So in this case, oh, I didn't write it. Magnitude of U was 25. Here's the rest. Okay. So that'd be 25 times 5 times cosine of 120 degrees. Let's see. Do they want the exact? Nope, they do not. So we can just type it straight in. That'd be 25 times 5 times cosine of 120 degrees. We do get this answer right here, 62.5 degrees. Or sorry, negative 62.5. Can't have that. So all we're going to do now is just add the 180 to it because it has to be positive. Oh, but they're accepting that. Oh, okay, cool. Then we don't have to worry about it. So therefore, they will take the negative value. So it's just going counterclockwise, but they're good with that. I was going to say, if we're in the negatives here, I could add 360, not 180. Sorry, I could add 360 to get a better answer, but they're accepting that one. So if they're accepting it, we'll keep it as is. The next one we'll look at is number 35. It says find two vectors orthogonal to the given vector. So you are given 3, negative 3. To find something that's orthogonal, we have to figure out something in which when I do the dot product, I get 3 times something plus negative 3 times something, and I get 0. All right, so you can kind of look at these. Obviously, it can't be the vector 0. But you might go, well, I could just make this a 1 and make this a 1, and then therefore that would give me a measurement. So it's kind of like solving what two numbers plug in, that would give you 0. So your vector v then would just be 1, comma 1. Right? Now, it says find 2, right? To find a second one is super easy. Just find, let's call it w, just any multiple of the orthogonal vector you found. So if you want, you could just do 2 times v. So that would just give you 2, 2. So that's just an extended line that's orthogonal to that point. So that would have been good too. All right, let's look at another example. Let's look at number 39. All right, so determine whether u and v are orthogonal, parallel, or neither. This is what I was talking about earlier. So if u, where are we at? Number 39. Okay, is equal to 2, negative 3, and v is equal to 1, 6. Determine if it's orthogonal first. That's the easiest thing. So we'll do u dot v. So this will be just 2 times 1 plus negative 3 times 6. That gives me 2 plus negative 18, which is negative 16. Therefore, not orthogonal. Okay. Okay. So then once you determine this one, you just got to ask yourself, all right, is u or v a multiple of each other? Meaning, can I factor something out of these numbers in which would give me this one? And really and truly, when I look at 2 and negative 3, I don't even see anything in common. 1 and 6, I don't see anything in common. So is there a way to make 2 become 1? I can divide by 2. But when I divide by 2 here, it doesn't make it 6. To make negative 3 turn into a 6, I'd have to multiply by negative 2. But when I multiply this by negative 2, it doesn't give me 1. So therefore, they're not multiples, so not parallel. So in this case, it is neither. So that's how you kind of determine. So you start off with orthogonal. Is it orthogonal? Because if you get 0, you're good to go. And then you go, all right, is the two vectors multiples of each other as a scalar? If it's not, then it's not parallel. So therefore, it must be left with neither. All right. So let's look at another type of example. Let's look at number 43. This one's asking you to find the projection of u onto v. So I'm looking for the projection of u onto v. And then write the u as a sum of 2 orthogonal vectors, one of which is the projection. Right? So we'll look for the projection first. So that would just be equal to u times the dot product of u times v over the magnitude of v squared. We'll take that result and multiply to the vector v. So here we go. You are given 2, by the way, on number 43. U is equal to 1, 3, and v is equal to 4, 2. So here we go. So when we do this, this will be 1 times 4 plus 3 times 2. Then the magnitude of v squared. So really, I'm not needing the square root. I just need to do this squared. So this would be 4 squared plus 2 squared. So that would be 16 plus 4, which is 20. So this would just be 20 times the vector v. So that's going to be 4 plus 6. 4 plus 6 is 10. 10 over 20 v, which is 1/2 v. So therefore, this is going to be 1/2. V was 4, 2. So that gives me 2, 1. There's the first answer. Now it says now write u as a sum of 2 orthogonal vectors, one of which is for the projection. So since this is the projection, I need something that's perpendicular. So to find something that's perpendicular, again, I need to find a vector in which this projection, let's call it, I'm going to call it W, in which V times, oh, shoot. So we need a, what's another one? We'll go with T. We need a W times a T that equals 0. So in this case, I need something, I need something 2 times what plus 1 times what would give me 0. I can put a 2 here. Ooh, there we go. I can put a 2 here and a -1 here because that right there would give me -2 and 2. So therefore, my other vector would just be -1 comma 2. There you go. So now you found where these two could be added together to be orthogonal of each other. There's your part. I think they call this 2. It's perpendicular, but they call it perpendicular of u onto v as well. So you might see this notation. All right, just a couple more and then we're good to go. So let's look at number 51. All right, 51 says find the work done on a particle moving from J to K if the magnitude and direction of the force are given by F. So you're given J is just 3 comma 0. You're given K is equal to -4, -2, and you're given the force is equal to -I plus 2j. So this is a vector. These are just coordinates. So they do give you one more formula in the book. I forgot to write it down, but the work would equal the F times the D, which is the same thing as the magnitude of D times the magnitude of F times cosine of theta. So that's what this would be. So we have to kind of find D first by figuring this point out. And it goes from J to K. So this would be the first point. This would be the second point. So you would go -4 minus 3 and then -2 minus 0. So this would then be -7 and -2. Now that you have a vector D and you technically have a vector F, we can kind of work these out. So the magnitude then of D would be -7 squared plus -2 squared. So I give you 49 plus 4, which is the square root of 53. And then the magnitude of F would be -1 squared. Remember, there's not a number there, it's imaginary 1, plus 2 squared. So you get 1 plus 4, which is the square root of 5. Now that you have everything you need, you really just need theta. So you need to find the angle between these. So to do that, we just do cosine inverse of the dot product of D and F. Could I just do, am I doing way too much? I feel like I'm doing way too much. Hold on, let me do this real quick in my head. Once I get D, that would be 7. Oh my gosh, I am doing way too much work. If I'm looking for F and D, once I find, oh goodness. Once I find D here and I already have F, I just need to do the dot product. That's what it's asking. I'm using a lot harder problem than what it's asking for. So if I do F and D now, I can just do, all right, well, that's -7 times -1 plus -2 times 2. The reason I stopped there is like, I'm about to have to do the dot product to find the angle. Well, so that's not what it's asking. Just wanted to know the dot product. So that'd be 7 minus 4. So 3. So there'd be a force of 3 there. All right. I'm glad we saw that before we did too much. All right. Last two questions are word problems. So let's look at number 54. Number 54 says a child sits in his go-kart at the start position of a race atop a hill. If the hill has a slope of 3 degrees and the child and go-kart have a total weight of 250 pounds, what force is required to keep them stationary at the start position? All right. So the first thing we need to do is to find, well, the main goal is to find force. Force happens to be the magnitude of our projection of V onto U. So now we have to go find the projection of V or U onto V, which remember is U times V over V squared times the vector V. And you're like, great. Now we have to go find U and V. Well, U is just going to be the weight of the child. So that would just be 0 because there's nothing happening on the X direction, but then the child itself would be coming at you at 250 pounds. And then the V would then just be since it's going down, you would have a negative cosine of a slope of 3 and then negative sine of slope of 3. So that would give you negative cosine cosine of 3. So that gives you negative 0.99863. And then we'll do the sine one. And that would give you negative 0.052336. All right, so now that we have all this, let's find the projection. All right, so that's going to be u dot v. So that's going to be 0 times this guy, which is 0, plus negative 250 times that. So I'm going to go back to my calculator. I'm going to multiply by negative 250, and I actually get 13.084 over the magnitude of this squared. So I need to square each one of these numbers. So let's do that in the calculator. I'll go back up to the cosine answer, square it, plus go up to the sine answer, square it, and then take the square root of that answer. Oh, why did it do that? It gives you 1, positive 1, and the square root of 1 ends up being 1. Man, that's nice. Times v. So this ends up just really being 13.084 times this vector v. Which will then give me, so let me go back to that answer, multiply that by 13.0, well, hold on, let me do that better. And that would give us negative 13.0661. And then we'll take that negative answer there for sine, multiply it by that 13.084. And that will actually give me negative 0.684763. All right, now we have to take that answer and find the magnitude to find its ultimate force. So then we go back and we just square those two numbers. All right, and it's like 171.191. So now just take the square root of that answer. So we get really 13.084 as our answer. What if I could have just stopped a lot earlier there? Yeah. So with that said, I wonder, that's only because this ended up being 1. I don't know if that'll happen. It has to happen every time with this. So, okay, so I guess an easier way to do this, and I don't know if it will work every time, but I guess I could have just done um, the dot product. Yeah, I could have just done the dot product of u and v. That's what equaled 13.084 to begin with. So again, that might work every time. Might want to trust this process, but if you do a few of these and you keep on getting this answer, maybe that's the way to go. All right, last question is number 57. So a child pulls a sled over the snow, exerting a force of 25 pounds on the attached rope. The rope is 35 degrees from the horizontal. If the child pulls the sled a distance of 80 feet, what work has been done? All right, so we first need to find our F, which is our force, because the ultimate, so using that formula from the book tells us our work is equal to the dot product of F and D. So if we first find our force, we can see that that's going to be 25 pounds. That's going to be like your magnitude. And then we have a 35 degrees. So that's going to be 25 times cosine of 35 degrees, and then 25 times sine of 35 degrees. And then for our D, since the distance is 80 feet that's being pulled, that would be your X direction. And then there's no up or down, so there's no Y direction. So there's your two stuff. So then we just got to figure out some answers by doing the dot product. So the dot product of F and D would just basically be 80 times 25 times cosine of 35 degrees plus 0 times 25 times sine of 35 degrees. So in reality, I don't need to do that part. I just need to do this part. So let's see what we get. So that'd be 80 times 25 times cosine of 35. And it comes out to be 1,638.3 feet per pound of force, or sorry, of work. All right, and so there you go. That pretty much kind of clears up all those questions. Curious about that number 27 still. Maybe it's like I said, I'm thinking I might have made an error somewhere, but I looked at it 2 or 3 times. I didn't see any. Hopefully y'all do, or maybe the book made an error. But if you do need more examples than that, please reach out and let me know. Until the next video. Bye.